Hello everybody, welcome to today's lecture. So today we're going to dive more into chapter 2. We're going to start with 2.2, but we did already talk about most of 2.2. A good half of this chapter is talking about the combining term stuff, which I put into the last section. So there's only a little bit more we need to talk about in this section, and that's just evaluating algebraic expressions. Okay. So evaluating algebraic expression. Actually, before we move on to this, let me do a little tiny review of what we did. Let me move this. Let me do a little review of what we did last time. Okay. Which was the order of operations. We did it at the end last time. Okay. Because this is pretty important. It's something that follows you kind of no matter what area of math you're in, no matter what kind of math you're doing. It's something you always need to remember. Even if you're using a calculator to do this stuff, it's still important to know this order because different calculators will handle order of operations differently. For example, if you have a typical Android phone, the calculator will work so that you can type in everything exactly how it is, and it'll evaluate it based on the order of operations here. But if you have a typical iPhone, the calculator on the iPhone is different. You can't typically type in everything at once and have it evaluate everything. You have to put it in the order that you want it to be evaluated in. So you would need to put the parentheses in first, then the exponent, then the multiplication, and so on. So if you're using an iPhone calculator, you typically will want it's more important for you to know the order of operations so you know what order to put it in. Unless it's changed recently, I haven't looked at one in a couple of years. If you're using just a regular calculator, not on your phone, it's really hard to say because there's so many different calculators out there. They all vary. But a lot of the time you're able to just put the whole thing in and it'll evaluate it for you. But if you have a little tiny one or a really cheap one, like a dollar calculator or something, there's a chance it'll work like the iPhones where you need to put it in the order that you want it evaluated in. Okay, it's hard for me to say without looking at the individual calculators. But anyway, let's remember what this is. All right, so you can remember the acronym PEMDAS, or you can remember the mnemonic device, please excuse my dear Aunt Sally. All right. The important thing is you remember what these letters stand for. Okay, so we have parentheses. And if you want to be a little more general about it, you can think of it as brackets. Or really, I mean to say grouping. Any kind of symbols where you're grouping things together. So this could be parentheses. It could be brackets. Sometimes we'll use these curly brackets. It could be the absolute value signs. I don't know if we'll really talk about that in this class. You might not really see that at all in this class or the next class. But if you ever took something like college algebra or pre-calculus or calculus, you would run into the absolute value signs quite a bit, or maybe like a physics class or something like that. And fractions also. So if you have x over y or something like that, these are another type of grouping symbols. There's kind of implied parentheses around the top and implied parentheses around the bottom. So even though the middle symbol right here is a division symbol, we never do that until the very end because we evaluate the top first, evaluate the bottom first, then we do division. So that's another type of grouping. Let me add this to the side over here. Okay. But we'll mainly need parentheses and the brackets, the first two. And of course fractions, but I think it's easier to remember with fractions. We typically don't even really think in terms of the order of operations. Exponents. Okay. This would also include roots. We'll talk about later like square roots, and you can have bigger roots than that, like cube roots and fourth roots. But when you're taking the square root of something, that it would take place on the same step as the exponents. The reason for that is because exponents and roots, they're really the same thing. But we'll talk about that later in the exponent chapter. But just know that if they do come up, you shouldn't have any problems with roots in them right now. But if you ever do run into this problem, you should do the roots in the same step you do the exponents. So then we just have our four standard operations, multiplication and division. And remember, these go together. Okay. So you should do these left to right. So you don't do multiplication first and then division. Once you have multiplication and division and you're on that step, you should do them in the order they appear, left to right. Okay. And same thing with addition and subtraction. So we don't do all the addition and then do all the subtraction. We count them as the same step and evaluate them left to right. Okay. Give us a little more room here. Man, that part really doesn't want to come along, huh? Oops. So let's do one example here. I'll do it on the side. I'll just make one up. Let's say yeah, that's fine. So we have bracket 7 times parentheses 3 minus 1 end parentheses whole thing squared minus 4 end bracket divided by 8. So we want to look at what we should do first, okay? So looking at the problem as a whole, we have two options here. We have the brackets and the division. But brackets fall under the grouping category, so we should go for that first. Now looking inside the brackets, we have multiplication, exponent, subtraction, and parentheses. Okay. So multiplication, parentheses, exponent, subtraction. Out of all of those, parentheses goes first. Okay. So now we're on this parentheses. There's only one thing to do in here, and that's subtraction. So we'll just go ahead and do that. So 3 minus 1 is 2. Okay. Now we can head back in here because we already established this part's going first. Now we have multiplication, exponent, subtraction. So if you look over here, exponent is the one that comes first. Okay, so we do the exponent. 2 squared is 2 multiplied by itself. So 2 times 2 in this case. Remember, the exponent, you're multiplying it by itself. Here it happens to be the same thing. 2 squared and 2 times 2 are the same thing. But if you had 3 squared, remember you're doing 3 times 3. You're multiplying by itself. Okay. So now we're still working in the bracket until we're done. We have multiplication, subtraction. So multiplication comes first here, right? So we have 28 minus 4 divided by 8. Now there's only one thing left in the bracket, and that's subtraction. So we get 24 divided by 8. And now finally there's only one thing left, and that's division. So we get 3. Okay. So like I said, there's There's lots of examples in the book if you feel like you want more practice with this, and there will be lots of them on the homework too. So you'll get plenty of practice with it. But make sure you have this, either the acronym or the mnemonic down so you remember the order, and especially remember the multiplication and division go together and addition and subtraction go together. Those are probably the two most often forgotten steps, is that multiplication and division go together and addition and subtraction go together. And it is important because it'll lead to completely different answers. So be sure to have that down. So let's talk about evaluating algebraic expressions now. So a definition here, to evaluate an algebraic expression. First of all, remember what an expression is. An expression is just a collection of terms put together by addition or subtraction. So something like x plus 3 is an expression. You could just have a number. You could just have a variable. Any combination of numbers and variables with addition and subtraction in there, just numbers and just variables, any of those would be expressions. Algebraic expressions, it's not really any different. Typically, algebraic just implies that there's a variable, so you wouldn't have something like 3 necessarily, though it does still count. Algebraic is just putting emphasis on the fact that there's probably a variable there. Okay. So to evaluate an algebraic expression means to find the value of the expression when the variable is replaced by a given number. Okay. So we find the value of an expression when the variables are placed by a given number. So for an example of what a typical problem would look like, it would say something like evaluate x plus 3 when x equals 11. Okay. So it gives you the expression that you want to look at, and then it tells you what number you should put in for the variable. So what we want to do is we just want to go over to the variable and replace it with whatever the given number is here. So in this case, x equals 11. Okay. My pen isn't working, so I'm going to write with the mouse for a second here if it lets me. It does not want to. Give me 1 second while I fix this. Okay, I think I got it working now. So we want to evaluate x plus 3 when x equals 11. Okay. So we just want to take that 11 and replace the x in the expression here. Okay. So instead of x plus 3, we're going to have 11 plus 3. Okay. So now we just have to do this and we get 14. Okay. So our answer would end up being 14. Let's take a look at another example. One that's maybe a little bit more common. So oftentimes it'll give us an expression like, let's say, evaluate 2 to the x power when, and then it's going to give us a couple of different variables to use. Okay, so x equals 2, x equals 4, x equals 8. So let's try all of these. Okay. And I'll change the color for the answer here. So for A, let's say x equals 2. So we want to replace the x in the expression that's right here with 2. Okay, so we get 2 squared, which is 2 times itself one time, right? Or there will be 2 copies of 2 rather, right? 2 times 2. So we end up getting 4. Okay? Now let's try B. So we want to do 2, and now we're going to have to the 4th power instead, right? So we have 2 times 2 times 2 times 2. So one thing we haven't talked about is if we only have multiplication, we can actually do this in any order we want. So we could kind of group these two together and group these two together. Because now it's like we already did this problem. We already found 2 times 2. So it's just 4 times 4, because that's what both of these are. So we get 16. Okay. Or you can just do 2 times 2 is 4, times another 2 is 8, times another 2 is 16. Okay. For C, x equals 8. So now we have 2 to the 8. So now it's going to get pretty big here. So you can just sit here and do it manually, or you can use, again, we already did 2 times 2 times 2 times 2 up above, right? That's what the last problem was. That's 2 to the 4th. So we just have to do that twice. So it's really 16 times 16. Then we can just do the multiplication, right? You can do it by hand if you like. This is 36. 6 plus times 1 plus 3 is 9. Put a 0 down here. 1 times 6 is 6. 1 times 1 is 1. Add them together. And we get 256. Okay. Or at this point, you can just use a calculator also. All right, so this is what a typical problem would look like from this section. You just want to, the main idea is taking whatever value it gives you and replacing the variable with that value. Okay. All right, let's move on to 2.3 now. Because like I said, we already did the rest of 2.2. So we don't actually need to, we don't need to cover it again, of course. So let's talk about 2.3. 2.3 is a very important chapter because it's the first time we encounter what's called an equation, and specifically an algebraic equation, meaning that we have an equal sign and we have a variable which we don't know the value of. Okay. So just remember what an equation is first of all. An equation is, I won't write down the definition again, but it was the definition we had was that it's a statement that says two expressions are equal. Okay, so for example, I think this is the example we had last time, x plus 3 is equal to 5. Okay, and we said before that x has to be 2 here, right? That's the only possible number x could be, because it's the only number where you add 3 to it and you get 5. So, okay, we figured that out, but what if it's more complicated, or what if the answer just doesn't come to us right away? How do we know exactly how do we figure out what the answer is? Like if it's something a little more complicated, like x plus 71 equals 333. Okay. It's not so easy to figure out what x is now because these numbers aren't small, and I could just make them even bigger and then it's going to be even harder. So what do we do? Well, first of all, what is it exactly that we're looking for? We're looking for what x is. And this is called a solution to the equation. Okay, so a solution to an equation is a value of a variable that makes the equation a true statement. What do we mean by that? Well, remember the equation is a statement that the two expressions are equal. So for x plus 3 equals 2, for example, if we plug in 2, then we get 2 plus 3 equals 5. And if we evaluate the left side, we get 5 equals 5. So this is true, right? Because we know 5 is equal to 5. It's the same number. If we plug in 3, then we get 3 plus 3 equals 5, so 6 equals 5. This is not true, okay? In other words, it's false. Okay. So 2 is a solution, 3 is not a solution. Can we have more than one solution? Well, in this equation, no, right? There's only one number that's going to work. How do we really know that, though? Well, it's hard to really say for sure in this case. We just really have to use what we know about addition. So I guess a better question would be, what is an instance where there is more than one answer? It's hard to talk about that without talking about negative numbers. I'm trying to think if we even can. I don't think we necessarily can without talking about negative numbers. So I guess that's something we would need to come back to. So let's just well, actually, here's one. What if we just had something as simple as x equals x? Okay. So this is an equation. X is an expression. The other x is an expression, and this is just a statement that they're equal. So what is a solution to this? Well, if we plug any number in for x, plug in, say, 100, then we're going to get 100 equals 100, right? And that's true. So in this case, any number is a solution. Okay. So we'd say that there's infinite solutions. So this is kind of one of the extremes. In this case, we have one solution, and here, any number is a solution. So there's infinite solutions. What if we have x equals x plus 3? Well, now what, right? Like, if I plug in any number, like let's just say 2 again, on the left side, I'm going to have that number. On the right side, I'm going to have that number plus 3. So 2 equals 5, right? And that's false. That's going to happen no matter what, because any number I plug in on the left side, on the right side, I'm adding 3 to it. There's no number where if we add 3 to it, it doesn't change it. So there's really nothing for us to do here. There's just no number that's going to work. So there is no solution. Okay. So there's no solution that works here. So these are kind of these are the two extremes here. One is where anything can be a solution. The second is where there isn't a solution. And then we have the case where there's one solution. So can we have cases where there's two solutions or three solutions? And the answer is yes. But we can't really talk about them without talking about negative numbers, so we'll come back to that later. But we'll see in general there are equations which have any number of solutions you would like. So this is how we check if something is a solution, right? We just put it in and see if the statement is true. But how do we come up with that number in the first place? What if we don't know what the solution is and we just need to figure it out? Like back in this one, x plus 71 equals 333. Well, there's two properties we can use to solve equations. There's actually many more than this, but these are the two we're going to look at first. Okay, so there's two properties we can use to solve equations. One is the subtraction property of equality. Okay. In plain English, this says that if you have an equation, you can subtract any number from both sides as long as it's the same number, right? So if you have an equation like x equals x plus 3, you can subtract 3 from both sides and have x minus 3 equals x plus 3 minus 3. Okay, and that's a perfectly valid thing to do. Let's write the definition first and look at an easier example than that. So in math, the way we would write this is as an if-then statement. If A equals B, then A minus C equals B minus C. So if A and B are equal, so A and B, they could be numbers, they could be expressions. It doesn't matter. All it matters is that we have this equation with two things on either side of it, right? Then we can take some third thing, C, it could be a number or an expression, and we can subtract it on both sides. So the idea is if A and B are the same thing, C is certainly the same thing as C. So we have like these two equations, right? We have A equals B, C equals C. All we're saying is we can combine these and make a third true equation. We can just subtract the equations and we get a third equation. Okay. So for example, if I have x plus 3 equals 5, then one clever thing I could do here is I could subtract 3 from both sides. Why would I want to do that? So I could subtract any number I wanted. Why pick 3? Well, notice what happens when I do it. Okay, on the left side, we have x plus 3 minus 3. 3 minus 3 is 0. So this ends up, whoops, sorry. This ends up just being x on this side. On the right side, 5 minus 3, well, that's just a number, that's 2, right? And now I have this new equation. So I had started with this equation, x plus 3 equals 5. I subtracted 3 from both sides in order to make this new equation, x equals 2. Well, why is this important? Well, this tells us what x is, right? We figured out earlier x has to be 2. And what we did is we took this equation and transformed it into this statement that explicitly tells us x must be 2. Okay. If I do that with that other equation we had, x plus 71 equals 333, I could do this same thing. I could subtract that 71, and I subtract the 71 in particular because what I want to do is make it so that on this side, all I have left is x. And then it'll give me a statement that says x is this. Okay, so now we don't have to guess anymore what x is. This 71 minus 71 is 0, so we just have x. So once we figure out what the 333 minus 71 is, that'll just tell us what x is. We don't have to guess anymore. All right, so we can do this in a calculator or on the side. 3 minus 1 is 2. Here we need to borrow. 13 minus 7 is 6. This is 2, so we get 262. Okay. So x is 262. If you're not sure, you can just go back and plug it in, do 262 plus 71, you should get 333. So there's always a way to check these. So this subtraction property of equality lets us cleverly subtract a number so that we're just left with a statement that says x is what. So how do we know which number to subtract? Well, it should always be whatever this number is, right? The idea is at the end, we want to get x by itself. We want to, what we call, isolate the variable. In order to do that, we have to get rid of all the things that aren't the variable on this side. Here, the plus 3 is not part of the variable, so we subtract that in order to get rid of it. When we subtract it on this side, we have to subtract it on this side also. Otherwise, we don't have a true statement anymore. Right? If we just subtract it on one side, then this equation would no longer be the same equation. The subtraction property of equality says we can do it as long as we subtract it on both sides. And what we're going to see as we go through this class is that you can pretty much do anything on both sides as long as you do it to both sides. Okay. So for example, the addition property of equality says basically the same thing, except for the fact that you can add anything you want to both sides. The addition property of equality this just says the same thing, but with addition. If A equals B, then A plus C equals B plus C. So we're essentially saying, okay, we have two equations, A equals B, C equals C. We can add these together to form a third new equation, or a third true equation. Okay. So we can add any number we want to both sides of an equation. When would we want to do that? Well, let's say we have x. Let me make that look like an A. It kind of looks like a 9. Let's say we have x minus 3 equals 5. So now if we have this and we want to get x by itself, if we subtract 3, it's not going to do anything, right? Because if you minus 3 twice, it's like minusing 6. Instead, we want to do the opposite thing here, right? Because subtraction and addition are opposites of each other. So if we add a 3 instead to both sides of the equation, here we have a minus 3 and a plus 3. These cancel each other out, and it's like adding 0, right? We're not doing anything here. Whatever the subtracting 3 did, the adding 3 undid it, and now we're just back where we started. So minus 3 plus 3 is 0, or you could think 3 minus 3 is 0. So on the left side, we just have x. On the right side, we have 5 plus 3, so that's 8. And now we have our answer for what x is. Okay, x equals 8, so we go back and plug it in up here. We have 8 minus 3 equals 5, that's true. So this gives us a way to figure out what exactly this number is. We can just subtract on both sides of the equation. We could also do both of these things if we wanted to. If we have something like this, x minus 3 plus 7 equals 10. There's two ways we could go about it. One, we could combine the 3 and the 7 first. But instead, let's use our other steps. Okay. We need to get x by itself. So we need to get rid of the -3 part and the +7 part. So we'll do it in 2 steps here. First, we'll get rid of the +7 part by subtracting a 7 on both sides. Okay. So this gives us a 0 right here so that the +7 is gone. And then we have x minus 3 equals 10 minus 7 is 3, so we get 3. And now we can add something to both sides. Just like we did in the last problem, we want to add 3 again to get rid of the -3. Okay, so this is 0 right here. So we end up getting x equals 6. Okay. So you can do both of these in the same problem if you want. You can essentially add and subtract whatever you want. You know, here we're strategically doing it with the -3, we're adding a 3. There's nothing stopping you from just adding 5 to both sides, and then you would end up getting x plus 2 equals 10. And that's still a true statement, and it'll lead you to the fact that x equals 8 still. There's just no reason to do that. We want to strategically add or subtract whatever this number is. And whether we're adding or subtracting depends on what operation this one is. If we start with subtraction, we want to add something to both sides to get rid of it. And if we start with addition, we want to subtract something from both sides to get rid of it. So let's do a couple more examples. Let's say, and it doesn't have to be x, it could be like y. Y minus 36 equals 44. Okay. Here we're subtracting a 36, so that tells us we want to add 36 to both sides in order to get rid of it. Now, you don't have to rewrite the step every time. You could just do like plus 36 like this. This is how you'll see it written a lot. Or you can rewrite the line like we did here. Okay. Either way you're comfortable with it. These cancel out and give you 0, so you just have y. And now you have 44 plus 36, so you get 80. Okay. We could have let me think of one. 14 plus x equals 28. Okay. So now the order is different here, but it doesn't actually matter because addition we can do in any order we want, right? So we still just want to subtract 14 from both sides, right? This gives us 0. So we're just left with x over here. And then here we can do the subtraction and get 14. 28 minus 14 is 14. So because we're adding a 14, we wanted to subtract 14 from both sides to get rid of it. Okay. So these kind of equations they're very important. It's probably one of the most important things we'll do in this class. Because this is like the heart of what algebra is being able to take an equation and figure out what your unknown is. This could be very useful in practical applications. For example, if we have something that's in the shape of a square, all right, let's not use a square. Let's use like a triangle where all the sides are unequal. Let's say we don't know what this side is, but we do know that, or here, let's use a better example. Let's say, no, that's fine. Let's say we don't know what this side is. We do know what this side is. It's 10. And we know that this side is 15. And we know that the total of all three sides is 40. Yeah, that's fine. So we know this side is 10. We know this side is 15. We know this side is something. We don't know what it is, but we know that they total up to 40. Then we can use this algebra to figure out what that unknown side is, because we know that x plus 10 plus 15 has to be 40, right? Now, we can just add the 10 and 15 together to get 25. And then we have x plus 25 is 40. And now we can just do what we just did in the last problems. We have a plus 25, so we should subtract 25 from both sides to figure out what that unknown side is, right? So we end up getting x equals 15. Okay, so the unknown side here ends up being 15. Okay. So we're often figuring stuff out like this without even realizing it, right? We don't like really write it out, but maybe we just kind of do it in our head and we don't really realize that this is what we're doing, but it is. So now we're just trying to like put that into math, put that into a system where we can work out more complicated problems that maybe we can't do in our head. Okay. So make sure to practice this. There will be lots of these ones in the homework for sure. So like I said, they're very important. And as we go on through the semester, we'll keep coming back to these equations and looking at different types of them. Like if we have something multiplied or divided, for example, and we'll just keep seeing, okay, we can usually do anything to both sides of the equation as long as we do it to both sides. So next time we'll keep going with chapter 2. And in that chapter, we'll start talking about multiples and factors and prime factorization, least common multiples, that kind of stuff in the next 2 sections. So I'll see you guys for that. Thanks for watching this video and have a great day.